Maker snack.
A project overview for those building the rolling and talking iOS-controlled, Raspberry Pi-based meal Mascaras robot. Now, if you have all the parts, this project shouldn't take more than 1 or 2 afternoons to complete. You can definitely get it done in a weekend. And there are lots of places where you can stop and take a break if you wanted to stretch this out with smaller time commitments. So here's an overview of the project and the build steps. Now, the times that I'm showing for each step are the lengths of the videos on YouTube. And in the videos, I speed up some of the steps so that you don't have to wait for things like installations. So plan on your build for each step taking longer, but at least this gives you a sense of the length of the video tutorials. A few things up front. This project is designed for beginners. There are a lot of steps, but I don't assume that you have any knowledge beyond the fact that you're able to use your Mac and an iPhone. Now, I talk you through all of the steps that we perform. I give you commands that you can copy and paste, and I give you all of the code and the scripts that we use for this project. But I do talk you through those steps that we perform so that I describe what we're doing and also go through the code that we've written, and this is a great way to learn so that you're not just parroting the steps without knowing what's going on. Now, if you're more experienced, you can watch the videos at double speed or just jump through the bullet points in the tutorial. And this project also doesn't require any soldering. So if you can use a screwdriver, you can build this project. I'll show you where the wires go and how to test things to make sure everything's working properly. Now, another thing that you might want to know, while the code to build the app is available for free on GitHub, the app to control the robot is also available in the iOS App Store. So you don't have to work with Xcode and build the app yourself if you're not an iOS developer. Those steps can be a bit complicated and time-consuming, especially for the newbie. Although the entire iOS course that I teach at Boston College is also free on my YouTube channel, so if you want to learn more about that, dig in. Now, the app that you can download from the App Store can also be used in ways beyond the specific robot. So if you want to give your Raspberry Pi a different name other than Meal Mascaras, the app will support that. Now, you can also use the app to just send sounds to be played remotely, which is handy if you want to create a project that embeds a speaker in a doll or another object and performs some high-tech ventriloquism.
Seeking Professor G, you are. Come to the right place you have.
It's always a fun trick. Or you can build and control this robot without the speaker, so the build instructions are actually more versatile than just the mask distributing robot. And of course, you can put whatever you want in the basket, and if you want to switch up the sounds, you can use the robot to promote events, to promote your business, to distribute candy, or whatever makes sense for you. Who knows, the people you're trying to reach might be more likely to take something from a robot than a person. And I share details on changing the sounds at the end of the instructions. Now, to build this project, here are the steps that you'll need. First, gather the parts. Now, here's a comprehensive part list with links to the items that I've used in this build, and I don't get any affiliate income from any of these sites. I do love the Adafruit company. They're founded by Lamore Freed. She was the first woman engineer to be on the cover of Wired magazine, and they manufacture their electronics right in New York City. They treat their staff well, they're civic-minded, and I tend to buy from that company whenever I can. Next, once you get your Raspberry Pi, your micro SD card, and a card reader that works with your Mac, you're ready to start setting up the software. Now, you'll want to set up your Raspberry Pi so that it can work on your Wi-Fi network. The step-by-step instructions are in the document linked in the description below this video, and in there you'll find a link to a video that can walk you through these steps as well. Now, if you're a newbie and you want to follow the rest of this tutorial without having to change any code, then in this tutorial, when you rename your Raspberry Pi from the default name Raspberry Pi to a new host name, be sure to call it Meal-Mascaras, spelled exactly as you see it here with lowercase letters, MIL-MASCARAS. You can always change this later once you have everything working, and I show you how to do this at the end of the instructions. Next, you'll want to install the CircuitPython programming language, and in these instructions, you'll also upgrade your Raspberry Pi to support a bunch of things that might not make sense to a newbie. These are SPI, SPI, I2C, and GPIO, but if you're new to this, the steps that you'll follow in this tutorial should set up your Raspberry Pi for all sorts of future work and future projects, whether you're working with motors like in this project, doing breadboard work, setting up a sensor like we do in the Smart Medicine Cabinet project. So these are good steps for anyone to follow that'll cover at least the initial setup for most projects using CircuitPython and a Raspberry Pi. And again, a link to step-by-step instructions is in our instruction document, and there's also a follow-along video. Now, this next step that I'm showing you don't have to follow, but at this point, you might have spent a decent amount of time copying files and configuring things. And if you think that you're going to be doing more Raspberry Pi projects, this tutorial here will walk you through the steps in making a copy of your micro SD card as a backup image that you can save to your Mac, and then you can just flash this image onto a new micro SD card. Flashing the image onto a new card only takes about 4 minutes, so that when you work on future projects, you can avoid all the setup that you just performed. This can also be really useful for educators that want to get configured Raspberry Pis out to all of their students and avoid doing all the steps that we just performed. Just create one image and then flash them onto multiple cards one by one. Either you can do it yourself or you can give the image to your students. You can tell them where they can download the free etcher software and they can flash the image themselves. Now, if you do this, you're going to need enough space on your hard drive to store the image, say 32 gigabytes if you're copying a 32 gigabyte card. And if you don't have that storage, remember you can save it someplace else like a Google Drive. But again, if you're going to do more Raspberry Pi work, this might be a time saver. Up next, we set up the Raspberry Pi to work with the Mac Finder. This way we can simply download the project files from GitHub and then copy the folder with all of our sounds over, just like we would drag and drop things on the Mac. Now, if you don't have a Mac, I've also updated the instructions to show how you can type in the wget command to copy the folder of files over. But since this is an iOS project, most of you are probably Mac users, and it's nice to know how you can drag and drop files between your Mac and your Raspberry Pi. So if you go through these steps, your Raspberry Pi will connect your Mac over Wi-Fi, and it'll show up in your Finder and work just like a flash drive that you would plug in through your USB port. Next, if you have your speaker, you'll be ready to set up your Raspberry Pi so that you can write Python programs to play sound, and we'll give you some sample code to try this out. So to be clear, for this project, you don't have to write any code or read Python. I'll give you all the code that you need, but I'll also walk you through the code so that you can get an idea of what's going on, and you can use this code as a starting place if you ever want to start experimenting with your own programs. Now, as part of this, we're going to install some extra files that extend the Python programming language to play sound. That's not something that Python normally does. And to do this, we're going to use something called the Pygame Python libraries. It's one of the easier to use and more popular ways to play sound in Python. Next, once you've got the rest of the parts you'll need for this project, it's time to actually build your robot. So your build guide has the steps along with photos, and there's a video to show you exactly how I put mine together using the parts that I've recommended in the parts list. I try to point out any gotchas that you might encounter during the build. It's pretty easy to assemble, and while I use this project with college students, frankly, a middle schooler that can follow instructions shouldn't have any problem with this either. And again, one of the reasons why this is a great newbie project is because it requires no soldering. It's a great classroom project for educators that don't have soldering irons or that aren't ready to put 650-degree rods of heat in the hands of their students. And when you're done with this step, it's always satisfying when the physical build comes together. Next, we're going to extend the CircuitPython programming language with some additional commands or additional libraries so that it can work with motors that we just wired up into our robot. And I love CircuitPython, so we're going to use these libraries, but to extend the language to work with the motors, we need to modify 3 lines of code to work with the inexpensive Waveshare motor hat that I've listed in the parts list. Now, you won't need to make any of these changes if you're using the Adafruit motor hat instead of the Waveshare hat, and I'll show you exactly how to make these changes, so don't be worried if you've never modified a Python library before. It's just 3 lines of code, and I take you through that step by step in our instructions in our video guide. Then we create a test program in Python to make sure that the motors are working properly. And again, I give you this program, so it's just copy and paste, but I walk you through the code if you're curious how things work, and this is useful if you want to modify this code for any future projects. Now, the version of the test program that I wrote works with the Waveshare motor hat, but if you bought the Adafruit motor hat, I'll also point out a very small change that you need to make. Now, for our next step, note that we have an iOS app and a Raspberry Pi computer that runs our robot. Now, to allow the Pi to receive messages from our app, we're going to use a special communication standard called MQTT. Now, don't let the acronym intimidate you. It's just a standard the iOS app will use to send commands, move, change volume, play sound, and we'll also set up software on the Pi to receive these commands with the same standard and then make the robot do its thing. So to make this happen, we're going to install some software on our Raspberry Pi to listen for the iOS commands. Now, this software is called Mosquito. It's a free open source product that supports the MQTT standard. Again, you'll get a step-by-step set of instructions on how to set this up. Now, MQTT is also a very popular standard for the Internet of Things, so this is also a great topic for educators to introduce to their students, and you can use these concepts in lots of future projects as well. Then we'll download the final Python program that takes commands that Mosquito receives from the iOS app and translate these into robot movement, volume change, and playing sound. Once again, we'll copy and paste the program so that you don't need to write any code, but I will walk you through the blocks of code so that if you're learning Python or learning how we use MQTT, motors, or play sounds, you'll see examples of all of this that you can copy and modify in your own code for future projects. Then we'll test everything to make sure that Mosquito and our code works fine on our robot, and we'll set all this up so that it starts automatically when you turn your robot on. Then all we need to do is download the Mascaras app from the App Store, make sure that your iOS device is on the same Wi-Fi network as your robot, and when your bot is turned on and ready to roll, you're in control and you're done. Also, as mentioned, I've got some extra info at the end if you want to change the bot's name or change the sounds with more or fewer or different sounds. So I really hope that you like this project, and if you use this material, please let me know. Creating YouTube content is sort of a lonely endeavor unless I actually learn that others are benefiting from this. So if you're following along, please post a comment, like a video, tweet, or otherwise let me know. I'm not trying to sell you anything. I just want to make sure that I'm making a difference, and this definitely keeps me motivated to keep producing more free content for students, educators, and independent learners. Now go out there and make something awesome.